class for this course. This is research methodology, and this is module 6, which implies that this is the sixth video, sorry, for this course. And the topic that we'll be treating in this module is data preparation and statistical foundation. So in our previous module, I believe we treated that data collection and all. So in this module, if you notice, we've been able to advance to a step further to how to prepare data and statistical foundation. I believe this has to do with from raw data to meaningful insights. We've collected the data in our previous module. We've collected and gathered the data. So now, how do we now make this data that is being collected, which is a raw data, to become a meaningful insight? This is what we'll be treating in this module. And for the contents of the module, we have different subtopics that we'll be looking at here, in which one of them is data coding and organization for research analysis. So we'll also look at preparing biodata and variable data using Microsoft Excel. And then afterwards, move on to data cleaning, validation, and transformation processes. So after that, we'll also move on to descriptive statistics for research purposes. So if we are through with that, we'll move on to the next subtopic, which is computation and interpretation of mean, median, mode, range, frequency, and standard deviation. And also look at presentation of statistical data using tables and charts. Then finally, we'll be looking at the final subtopics that we'll be looking at here is writing statistical summaries in research reports. Then we'll move on to the conclusion for the module. Now, for the introduction of the module, we have that effective research, it mainly depends not only on sound study design and data collection, but it also depends on the careful preparation and correct statistical treatment of data. It's a different thing to correct or to collect data or to gather data, and it is a different entire thing to be able to prepare and correct and use the data effectively and use the data appropriately, statistically, or any form that it might come from. So this is what we'll be looking at in this module. So it has to do with it depends not only effective research depends not only on sound study design and data collection, but also on the careful preparation and correct statistical treatment of data. So this data that is being collected or that is being gathered, it's the ability to treat them very well, to use them appropriately, and statistically. This is very essential to research analysis or effective research. Now we also move on to raw data. That if raw data is not properly coded, organized, and cleaned, it can lead to misleading results and weak conclusions. If we gather data and if this data, if we don't know what to use it for properly, if it's not well properly cleaned and coded or even organized, it can twist the whole thing about the conclusion of our research. So this module is focusing on building strong statistical foundations by guiding learners through the systematic processes that is required to transform raw research data into reliable and analyzable information. So this module will introduce essential techniques for data coding, organization, cleaning, validation, and transformation by trying to ensure accuracy and consistency in research data sets. So this is all about this module and for the introductory part for the module. One thing that I want us to note is that appropriate uses of data or treatment of data is everything that tells all about the data that we've collected. So if it is not used appropriately or statistically right, it will lead to something else entirely, which will jeopardize the work that a researcher has been putting on for over the time. So let's move on to the journey of research data now. So for the journey of research data does not start off ready for analysis. You can't just get data and voila, you are ready for analysis. There is a procedure, that there are procedures and process, step-by-step journey that a data will pass through before it can be analyzed and before we can jump to a particular conclusion. So where we have let's take for instance, now we have raw data, which is the raw data that is being collected from different respondents or participants. Then from being a raw data, it's moved to preparation and cleaning. You prepare the data and you clean it appropriately. Make sure that you removed any error or anything that might jeopardize your work. Then you move on to descriptive analysis. That is where you have to describe analyze the data descriptively. Then interpretation and reporting. Try to interpret the outcome and reporting the outcome of the analysis. So raw data now, it has to do with unorganized responses, observation or measurements. Just something that is fresh and raw, that is, it has not been organized yet. Everything is just being collected directly. So now, and after it is being collected, you move on to preparation and cleaning. What does preparation and cleaning mean now? It implies the crucial, often visible work to make data usable. That is very crucial. Preparation and cleaning is very crucial, and it is invisible, whereby it is the work that make data usable. Before you can use a data, the process that it will have to pass through, preparing and cleaning the errors that can jeopardize our work. This is what we are trying to do. And descriptive analysis, that is, has to do with summarizing the data to understand its basic story, like summarize, giving a background or foundational summary of the data. Then interpretation is drawing meaningful conclusions, discussions from the data. Then this module focuses on the essential middle steps mainly. Now let's move to data coding and organization. We are talking about the journey of research data. Step 1 is data coding and organization. To do that, it has to do with translating data into an analyzable format. So data coding, it has to do with assigning numerical or categorical labels to responses. Example of that is gender, which could be male equals to 1, female equals to 2. Likert scale, strongly disagree equals to 1, strongly agree equals to 5. With that, we'll be able to the researcher have been able to analyze to assign numerical or categorical labels to different to different categories, or categories for the analysis. Why code? So now let's look at why code. Because it makes data uniform, it reduces errors and allows software to process it. Now let's move on to data organization. Now we're able to data coding. Data organization, it has to do with structuring data into a clear logical format. So, and to do this, you have to think, create a code book. You think row and columns, 1 row per respondent or observation, 1 column per variable. You understand? Make sure the work is well organized in row and column. So now creating a code book, it has to be a master document that defines everything that you have to do. You understand? So now let's move to preparing data in Microsoft Excel now. A practical toolkit is Excel, which is a powerful tool for early stage data. So now the structure, you try to set up your sheet with clear headers. The headers in the sense that something that is very clear, that will be very easy for anybody to understand when they pick your work up. So it could be e.g. respondents ID, age, or income. You understand? Respondents ID, respondents age, or respondents income. Something just clear as headers. You understand? So now then we have data validation. You use your Excel's data validation to prevent entry errors, e.g. you switch age to numbers, 18 to 20. You understand? It could be just that the range is from 15 to 100 of age and the likes. Then cleaning function. I move on to the cleaning function, and to do this you use sort or filter to find outliers, or find or replace to fix typos and remove duplicates. And then preliminary check, and by doing this you use simple formulas: equals to average equals to count, to spot check your data as you enter it. So Excel will help you find out help you build a clean structured data set before moving to specialized statistical software. Now the second step is cleaning and validation, and to do this you have to find, and that is cleaning and validation, data cleaning and validation. It's mainly this with finding and fixing the garbage. You've gotten your data. Now finding and fixing it, that has to do with cleaning and validation. So when data is raw, it is very messy and dusty, so cleaning is very essential and mandatory. So common issues to hunt for when we want to do data cleaning and validation is: one is missing values, outliers, inconsistencies, duplicates, and all. So let's talk about missing values now. This has to do with blank cells, while outliers has to do with extreme impossible values, e.g. age equals to 150. How come? So now inconsistencies could be male versus male versus VS1 and the likes. So duplicate, the same respondents enter twice. You try to make sure you do your fixing and cleaning very well. Make sure there is no duplicate and not entered twice. And validation has to do with continuously ask, does this entry you try to ask yourself, does this entry make sense given the use of my study? So garbage in, garbage out. Your clean data is non-negotiable for credible results. Now let's move on to the next step, which is step 3. And for this step we have the descriptive statistics, which is otherwise known as the what. And this has to do with summarizing your data story. The descriptive statistics, yeah, it gives you the first snapshot. It gives you the first headshot of what the work is all about, the purpose and all. So the purpose of this is to summarize, organize, and simplify your data to understand its basic characteristics. You bring it to the minimal basic level form. You understand? So now, quick questions that this descriptive statistics has are: what does a typical response look like? That's central tendency. So, and how to spread out how to spread out the responses, variability. Then you look at what is the distribution of responses, that is the frequency. You can't run before you walk, that's not possible. So descriptive stats are the essential first step in analysis. So measures of central tendency, we have finding typical value. We have mean, median, mode, that is mean the average, median the middle, and mode, which is most frequent. So mean simply means sum of all values divided by the count used for normally, as is usually used for normally distributed numerical data. And median, on the other hand, it has to do with the value that splits the data in half, the value that actually splits the data into half, and it is used for ordinary data or when data has outliers. While mode is the most frequent, and it has to do with the value that appears most often. So then the next thing is you try to measure measures of variability, and in doing this you have to understand the spread. Knowing the average isn't enough, So how much do responses vary? That's the most important thing. So range, simplest measure, that is maximum to minimum. So it's very sensitive and be sensitive to outliers. Standard deviation, that's the SD, which is the average distance of each data point from the mean. We have the under standard deviation, we have low SD and high SD. Low SD has to do with data points. Data points are clustered tightly around the mean, while for the high SD, data points are spread out widely. We also have variance, the square of the standard deviation that is used. It is used in more advanced calculations. So now let's look at frequency distributions. We have seeing the shape of your data. That is, frequency distribution has to do with you seeing the shape of your data, what it is, tabular presentation, visualization, why it matters and all. So let's look at what it is. Frequency, in when we're talking about frequency distribution, it has to do with it is a count of how many times each value or category occurs in your work, while tabular presentation is there to create a clear summary table. That it could be value, it could be count or percent in percentage. Visualizations, we have histograms for numerical data and bar charts for categorical data. For categorical data, I believe you know what histograms and bar charts are. They bring these distributions to life. And why all these things matters, we have one is that they review patterns, they review clusters, gaps, and potential data entry at a glance. So the frequency distribution is the first place you see that you'll be able to see your data. Now we'll be moving on to presenting data, which is tables and effectively. So communication is very essential. So we have the tables, we have the charts. So when we're talking about the charts, it could be bar charts, it could be pie charts, it could be histogram or line graph. Let's take for instance now we have the tables. I believe you understand what I'm trying to drive out here. We should take the table for instance. It is there for precision. That is best. It is best when readers need exact numbers to compare. You make use of the table. And the number one rule to do that is to always use the clear title. You label the row and columns. Make sure the formatting is very neat and clear. You just make everything sharp and clean. So how we have the chart is there for impacts and trends. So, and this is there and is best for showing patterns, proportions, and comparison. We have the bar chart, pie chart, histogram, and line graph. A bar chart is there to compare categories, while pie chart is there to show proportions of a whole. and histogram is there to show distribution of the numerical variables, while line graph is there to show trends over time. So in doing this, you match the visual tool to your messages, and a good chart tells the story instantly, even without you writing anything other than it. Once they see the chart, they will have able to understand and deduce what you are trying to pass across. So now this is a visual example of what we are talking about: a pie chart, bar chart, Instagram, and all. So let's move on to writing the statistical summary, the narrative of numbers. Your reports In writing a statistical summary, your reports must translate statistics into considerable insights. So a good summary must have the following: one, it must report the key figures, it must interpret the meaning, it must highlight the patterns and references visuals. It must also connect to the research questions. This is very important, connecting to research questions. So reporting the figure in the sense that the mean age was 45.22 years, which is equals SD is equal to 12.8. Interprets the meaning in the sense that this just suggests a mature workforce with moderate variability in age. Highlights pattern in the sense that 70% of respondents they lack access to credit, indicating a major financial constraint. And references visuals, it could be we can have it as shown in table 2. Cassava was the dominant crop, 40%, and blah blah blah. You understand? So now let's move on to the full process, that is a recap of what we've been doing since. So from chaos to clarity, when we get a raw material, it's more or less like it is just there, and it is very very chaotic in nature if it is not properly cleaned or not. So one, we have the code and enter. In doing this, you transform responses into structured data sets, which is mostly Excel is mostly recommended. And two, we have clean and validate. You try to clean your data and validate it, and in doing this, you try to hunt for you hunt and or for and fix errors, and you hunt for missing data and outliers and all. Three is you describing, and in doing that, you calculate mean, media, SD, frequencies to understand your data story. And the fourth one is to visualize, and in doing this, you try to create tables and charts to communicate patterns, or you communicate your story instantly and effectively. And finally, you summarize, and in doing this, you write a clear narrative that will be able to interpret the statistics and answers your research questions. So each step is built on the last. Skipping one compromises everything that follows. It is just like a sequential something that needs to be done. If you miss one or you try to skip one, it will definitely backfire or affect your work at the end of the whole thing. So now, common pitfalls to avoid. One is that you skipping the code book. We've mentioned that it will definitely lead to confusion about what one or two means months later. You understand? So, and not cleaning data. This is very essential. You must clean your data, and you not doing it, it will let typos and outlier distort your results. The third one is using the mean for skewed data. Using the median is often better for income, reaction times, and the likes, etc. And the fourth one, common pitfalls to avoid, is to creating misleading charts. And in order not to use it, using 3D effects, truncating the y-axis, or using the wrong chart type. And lastly, reporting without interpreting. You don't do that. This definitely, you don't do that. So you just listing numbers without saying what they mean is very very wrong. So these are the common pitfalls that you need to avoid. So rigor in preparation and honesty in presentation are marks of a professional researcher. In conclusion, that we'll be looking at the key takeaways and final thoughts. Data preparation is analysis. This is what this all the module is talking about, the summary of the whole module. Before your analysis has to is the data preparation is the backbone and foundation of what your analysis will look like. So you should never skip it or miss it, or even try to skip a step. You understand? So data preparation, when we are talking about data, which could be coding, cleaning, organizing, it is not administrative work. On the other hand, it is the work. It is the first and most critical phase of analysis. So descriptive statistics is there to